So in the previous session, we understood what is Agile, what is DevOps, why is there a need for DevOps, as well as the DevOps lifecycle. Then we looked at a case study of Facebook and how it used a technique called dark deployment to soak test its new features before it made all the new functionality available to its entire consumer base. And then finally, we were introduced to our three main tools, which we'll be using today in our demo session. We spoke about Git, Jenkins, and Docker. Hi all, I welcome you all again to the second and the concluding session of DevOps projects. Today we are going to be setting up a fully functional CI/CD pipeline for an e-commerce application. It is going to be a complete hands-on experience. It would be great if you had Git, Jenkins, and Docker downloaded and installed in your systems to follow along with me. But even if you haven't, you can all just go on and experience building this pipeline vicariously through me. So let's go ahead and look at our agenda for today. First, we'll be setting up the GitHub repository. As we had previously seen, Git is a distributed version control system, and today we are going to use it to understand how to coordinate work amongst various programmers with the use of their local and remote repositories, also using it to track changes in any set of files. Next, we'll be building a Jenkins pipeline wherein we look at how we can use Jenkins to obtain the code from Git as well as deploy the changes that have been made to the application via Docker. Followed by which we are going to be building and deploying our app via the Docker containers and push the Docker image to Docker Hub. With that, I come to the end of our agenda for today. Also, kindly take up this time to subscribe to us and don't forget to hit that bell icon to never miss an update from the Edureka YouTube channel. And if you want to learn DevOps and the many tools that it comprises of, you can go ahead and check out our DevOps certification training, the link to which I'll leave in the description box below. So without much ado, let's get straight into the module and look at the software lifecycle of our e-commerce application. So first of all, we have Git, which is going to manage all of our code whenever there is a change in features of our app or there is a bug which has been corrected. It is going to track the changes in our source code, and we'll be using GitHub, which is an online service, to connect, upload, and download our resources. Next, we have Jenkins, which is going to pick the code from GitHub. We are going to build and test our project continuously to integrate the changes to our particular application using Jenkins to in turn deploy it to Docker. So Jenkins is basically going to build an image which is going to be pushed to Docker Hub. So once Jenkins picks up the code, it's going to basically create a Docker image using the Docker utility and deploy it to a container using PHP and MySQL, and also push the created image to Docker Hub. So this is what our entire workflow looks like in its bare bones. So with that information in mind, let's go ahead and get started with our hands-on. So the first logical thing to start with is obviously Git. So this is what the inside of Git Bash looks like. So Git Bash is the source control management system for Windows. Here you can type Git commands that will make source code management for you much easier in terms of versioning and commit history. Everything I'm doing here you can also execute in Linux or Mac. You can just go ahead and look up alternate commands if you're using a different OS, but more or less most of the commands are going to remain fairly the same. So now, as a developer, if you're using Git, you may be in one of two scenarios. So the first scenario is that you join a team which is already in the middle of a project, in which case they will already have some code in place, maybe a repository in GitHub with all the code present there. So this is what your Git repository is going to look like. In front of you is my GitHub repository, and this is the project on which we'll be working today. Like I said, you might be in a scenario where you are joining a team which already has a project in place, in which case you'll have some code which everybody else is working on. In our case, we have our online shop or our online shopping system, the code to which is right here. So in a case like this, what you will basically do is you're going to clone that repository into your local system so that you can work on it. So in such a case, what our objective is that we are trying to set up a local repository. So this is our remote repository. It's a centralized repository which is accessible to all. So what we're trying to do right now is to set up a local repository in our system, assuming that I am one of the many developers who's using it through one of the many local systems or virtual machines, and we are all working on the same piece of code. Yeah. So what I'm going to do is, first of all, I'm going to go here, click on this green button which says clone or download. You can use an SSH protocol or an HTTPS protocol. Just copy it. So the first thing we're going to do is we are going to basically create a directory called sample repository. Okay, now let's see the path of this particular directory. All right, and now we are going to change directories and go inside this particular directory. All right, so as you can see here, we are inside our sample repo directory, and this is where we are going to clone our Git repository. So I'm going to go in here, click on clone or download, which is this green button in your repository. I'm going to select this URL. Now you can use either the HTTP protocol or you can use SSH if you feel like. I'm just going to stick with the regular HTTP, and I'm going to use the function git clone. And this is basically the URL of the repository that I've created for our online shop demo. And now it's going to start cloning our repository, and with that it's done. If I check what's there in my sample repo, you can see there's just one folder, which is the online shop folder. So what we've done, we've basically made a copy of our remote repository on our local systems. We've set up a local repository to which then we can make changes and then push it back to our remote repository for others to access. So now you have a local repository and you have a remote repository, and hence this is known as a distributed version control system. Now let's go ahead, change directories into our online shop, and we are going to see what all are its components. Here we see there are 4 files. You have Jenkins file, this readme doc, Docker Compose, and your PHP folder. If we go to my Git repository again, you see these are the same files which has gotten copied into our local system. So this is the case if you already have code in hand, if you are joining a team where a project is already under progress. This is one case. How to tackle a scenario in which you join a team, it's a new team, and there is no code in progress. You're basically going to do everything from scratch. Let's clear the screen and let's go back to our all right. So now let's look at a case in which you have no code. You're starting everything from scratch. There is no Git repository. So in the previous case, you imported your code from your remote repository to a local repository. So obviously in this case, when there is no code for you to work on in the remote repository, the logical thing to do is to create a project in your local repository and then push it to your remote repository. So again, we are going to start out with creating a new directory. So let's just name this Scratch development, or maybe Scratch repository, because we are creating our code from scratch and we are completely unoriginal. Let's go ahead and get inside our Scratch repo. All right. So now we have nothing here. This is basically a completely empty folder, as you can see. So how do you start working here? Now, before you want Git to manage any version of your code, you'll have to initialize your Git. So you're going to use the command init, and it's going to initialize an empty Git repository in a directory of your choice. Now, as soon as you've initialized your Git, the first thing I would like to do always is to check the Git status. By default, you're in the master branch and you have no commits yet, so obviously. And it states pretty much the obvious where it says you have nothing to commit. So right now your option is to create or copy files, for which you have to use the git add command. So what I'm going to do now is I'm going to open something known as a Vim editor. So right now I'm going to be creating a sample file, and I'm just going to name it sample. It's going to be in an HTML format. You can also use PHP, and inside this file you can code in any language. It could be Java, Python, it could just be plain text. The important thing to remember here is Git basically does not track what's written in the file. What it does, how Git works, is that it tracks the file itself and not what's written in the file. Even if it's simple text, this entire setting works. So I'm just going to type this is a sample entry. Yeah. I'll click on escape and I'm going to save the file. I'm going to use WQ. So now if I use the concatenate command, you can see what I've written inside the Vim editor. Yes? All right. So this is the only file in this folder. Yes? Let's clear it and see how we can push it to our remote repository. So let's go ahead and check our Git status again. Okay. So when we check for our Git status, Git informs us of its untracked files, which is our sample file. Now basically this is so because Git does not recognize this file yet. Basically any file in your working directory that was not your last snapshot and is not in your staging area is an untracked file. When we clone a repository from Git, all of the files in that repository basically are tracked unless and until you make edits in them. But since this project has been initiated in our local system, it has not been added to the staging area of Git. So obviously Git cannot track this file. Now to add it to the staging area, we are going to be using a command called git add, which is fairly simple and self-explanatory. And now if we check our Git status, you see now it says that in our master branch, we have a new file. And since it's in green, you know that it can be tracked by Git. Right now our file is in something known as a staging area. Staging is basically a step before the commit process in Git. From here on, the next step is basically to perform a commit. This is the first step to commit your file. As long as this file or any change set is in our staging area, Git will allow us to edit it. This staging also helps you keep your extra local files hanging around in your local system without having to push them into your Git repository. All right. So now what we have to do is we have to commit. So for that, again, a very self-explanatory command called git commit. While we're doing this, we have to put up a message as well. Now this is a great practice because it also helps labeling your commits. And understand that when you are performing a commit or when you are committing, this is just you putting up your file in your repository that you are connected to. That is whichever repository. In our case, it is our local repository. We have not yet pushed our file to the remote repository. All right. This is for our local repository or the repository that you're currently connected to. Very important, keep that in mind. So in my message, I'm just going to put up something which describes this commit best, this action best. So just going to name it updated sample HTML file, and we get a confirmation message. Okay. Now what will happen if we try to make any changes in this particular file? So if I open the Vim editor again, this is a sample entry. Let's add this line called, and this is an addition. One more addition, and one more addition. Okay, this one is last, I promise. So now we save our file. All right, let's see what's there in our file. All right, you have 4 lines in your file, and previously you just had 1. Now let's see what our git status says. All right, now as you can see, your file appears in red yet again, because you made modifications to that particular file. It's no longer the same snapshot that Git remembers. So it can track the previous version of the file, but not this version. So what we're going to do, we are going to make the addition again. So git add. Let me clear the screen, make it more visible. After we added our file to the staging area, all right, now you can see our modified file is again trackable by Git, and we have to again commit. All right, and as we commit, it gives you certain information such as the file that has been changed, the number of insertions, and the number of deletions that we made in the file. So now if you want to view information about this particular commit or any previous commit that you made, there is a command for that as well, which is git log. Now remember that we had made 2 commits. So this is the first commit that we made and the second commit that we made, along with the author, date, as well as the message in the commit. It's always a good practice to use a message which will make sense to your viewer and other developers using the code. Just a best practice tip here and there. So yeah, GitLog tool basically allows you to view information about your previous commits that have occurred in the project. Basically, this in its simplest form, like right now without any flags, basically will show you the commits that lead up to the current state. So we've made 2 commits and both of them show right here. And if I go ahead and type git show and select the first 5-6 characters, okay, so 1F6868, it's basically going to show you everything, every update that has happened under this particular commit. All right, okay. So at this point, we have initialized our Git, we have created a sample file, added the file to our staging area, and committed the file to our local repository. Now all that is left is to push this particular file to our remote repository. But before that happens, we have to establish a connection between our local repository and our remote repository. So our working tree is clean at the moment because we have nothing to commit. We have already committed the changes that we had to. So to establish this connection, we are going to be using a command called git remote add. Pretty self-explanatory again. You're basically going to add a remote repository, but we do not have any remote repository to add as yet. So we're going to go on to our GitHub and create a new repository for our sample file. We're back at our GitHub. On the right top corner, you will see a plus sign with a drop down arrow. Here I'm going to select new repository. Let's name it demo. All right, that's available, and the description is just going to be sample repository. Okay, let's again initialize a repository with a readme and then click on create repository. Now what we're going to do is something that we did the last time. We're going to click on clone or download the button. We're going to copy this particular web URL. Now we're going to go back to our Git and paste it. Almost immediately, it has set up our remote repository as a mirror to our local repository, to which we can push information as well as we can fetch from. So basically, all you have to do is use git remote add origin. Basically, you are adding your remote repository through this command, and your origin is basically the default name or an alias for your remote repository. Now, if you've copied a project from GitHub, it already has an origin. You can also use a particular command called remote with a verbose flag, which will list the URL of the remote repository. So as you can see, this is the URL of the remote repository that we have established our connection with. Now all that is left is to push our code to our remote repository for others to access. So now all that is left to do is to push our code. So for that, the command is git push, and then our repository's name, which is origin, we're going to call it by alias, and then the name of the branch, which every time you check the git status, it is going to tell you that you are on the master branch. So now if we reload our Git repository page, you can see our sample HTML file is there. And here you can see our file with our sample entry and all of this random text that there is. Let's go back to our repository. And that is how you guys can push a piece of code that you've created from scratch to your Git remote repository. And with that, we come to the end of this bit where you have created a code from scratch and pushed it to your remote repository. So now we did what we had to do with the sample file. Now you understand the whole concept behind pushing a file. So now what we have to do is we have to understand all of this from the perspective of our demo, our online shopping store, which we're working on. So let's change directories and check out our file. So we are inside that particular directory, and these are all the files that are present in there. Let me just quickly go and check the status. Okay, so our working tree is clean and a relationship has been already established. So let me just go ahead and pull the latest code from my repository. Okay, says I'm already up to date. That means there have been made no changes in my code and everything on both sides is already up to date. Now everything is up to date. So what if I go ahead and add a new feature? Let's say we'll call it new feature.html. and we save that. Now you see, instead of 4, we have 5 files. So like we had done it once before, we are again going to add and commit. With a tag saying added new feature. Okay, so now we've pushed the code. Let's go ahead and check if the code has been updated. And here you can see the new feature.html file has been updated. And with that, we come to the end of the first and the lengthiest part of this project. So the next thing that we are going to talk about is Jenkins. As I had mentioned before, we are going to be building a Jenkins pipeline, which is nothing but a combination of plugins that support the integration and implementation of continuous delivery pipelines using Jenkins. A pipeline here has an extensible automation server for creating simple or complex delivery pipelines as code via a domain-specific language. Now, when we open Jenkins, we will come across something known as a stage view, which helps us visualize the progress of various stages of your pipeline building in real time. It will look something like the screenshot in front of you. So from here on, I'm going to be using my virtual machine, and I'll be running all of the tools that I'll be running on a Linux platform. So here, if I open Jenkins, this is what the stage view looks like. As you see, you can see the different stages of my pipeline and whether they were successful or had they failed. If I go a little lower, you can see which parts of my pipeline were successful and which is the part which failed. So if I go back to my dashboard, this is what your Jenkins dashboard looks like. It'll be the UX you'll be faced with immediately after you log into Jenkins. So what you can do is you can click on this new item. Now, some people may refer to this item as a job or a project. The most commonly used term for this is a job. So let's just name it demo job or just demo. And we're going to learn how to use a pipeline. It's basically going to orchestrate an activity which can span over multiple build agents. As you just saw, the pipeline I was running had 3 build agents. Just going to go ahead and click on OK. All right. With that, it opens such a dialog box. You can create a description. I'm just going to write PHP MySQL app. And here you have various different options. You have build triggers, advanced project options, as well as pipeline. In build triggers, you can basically, as the name suggests, you can build your triggers. So you have multiple different options such as build after other projects are built, to build periodically, to disable this project, a quiet period, so on and so forth. So we're going to go straight to pipeline, and here you have a couple of options. You can try a sample pipeline, one of these 3. You can try your Hello World. It's a pretty simple pipeline, but it will definitely give you all the stages of building a Jenkins pipeline, and it shows them pretty clearly. Now, there are certain fundamentals when we talk about creating a pipeline, a scripted pipeline. So there's actually a certain template in which pipeline code is written. So first of all, you will start with a node. A node is basically a machine which is a part of the Jenkins environment. The pipeline node is actually where you install and start the pipeline executable. So this is the thing which is capable of executing your pipeline. Then you have your different stages. Most commonly, they are going to be your build, test, and deploy stages. A stage is a block which defines a subset of tasks which are going to be performed by your pipeline. So if we go back to this pipeline, here is your node, and then you have all of your stages. Each stage basically having a subset of the whole task that you are trying to perform via this pipeline. Here you're trying to print hello world. So there's technically just one step, but you can always put it inside a stage called hello, which will ultimately come under your main stages step. I'm just going to save it. And now we're going to try and build it. If we go down, you can see on the left, we're trying to execute this file. And because it had one step, you can see the one step is successful here. Hence, the build was successful. You can also go ahead and look at the console output. Here you can see the different stages of your file. And in the end, you see it finished as a success. And we are going to be doing the same thing for our project. Okay. So I'm going to go ahead and open the project. This is named job 1. And as you can see, it has 3 stages. One is your SCM checkout, second is your run Docker compose file, and then you have your pushing your image into Docker Hub. So if I go into configure, and if I go into pipeline, so as I had mentioned, there are essentially 2 ways to write code for a pipeline. Here in the second way, we can select pipeline script from SCM, and then we can select either of these. I'm going to be selecting Git because I'll be pulling my Git repository here. This is the repository link, the link which we clone from Git. And here you have your credentials. You can go ahead. If you have no credentials, it'll automatically be generated for you. You can go ahead and add credentials in Jenkins. You'll be prompted with a Jenkins credentials provider dialog box. Here you can put in your username, password for Git, Docker, or any other tool that you are using in your particular project. All right. So here I have put in the credentials for my Git as well as, I repeat, the credentials for my Git. So all of you might wonder what this particular pipeline looks like. So I'm just going to open my Git repository, the one that I've pulled, and show you the code for the pipeline. Again, we start with the node, and then we have several stages. We have 1, 2, and 3 stages. The first one is the SCM checkout, which basically is nothing but the source code management checkout. And here I have provided with the Git credentials of where the project originally exists. Then in the next stage, you're going to run the Docker compose file. Now there are 2 commands in here, very important. The first one is to build Docker compose. And the second one is to start the containers in the background and leave them running. Now you might wonder what a Docker compose is. I have kept that also open for you. Now when you're running more than one container, like in our case, we are running a PHP container for the front end of our e-commerce app, and we are running a MySQL container for the backend database. Yes. So for those 2 containers to interact, we are going to be using something known as a Docker compose. Here is basically a list of instructions of how the 2 containers should be interacting with each other. So as you can see, there is your versions, services, build, your context, which is in context of the online shopping system. You're going to be using the Docker file. The name of the first container is your PHP app. You have provided the volumes. You have provided the dependencies, which is a database. And then you have given the port in which it's going to be executed. So this is the dependent UX. Now what is it dependent on? It's obviously dependent on a database. So you have your database here, which is basically a MySQL database. Here is your container name, the image, so on and so forth. Then you have a few environment specifications. You have your root password, the name of the database, the name of the user, as well as your MySQL password. Also the port in which this is going to get executed. All right. So in the second stage, we are going to build and run our Docker Compose containers. And finally, we are going to push the image into Docker Hub. So this is Docker Hub. This is where I've pushed a bunch of different projects or pipelines, as you may call them. You can also go ahead and create a new repository like so, just by clicking a button. And this is basically like a huge library for container images. If I open a certain container, you can go to tags and you can basically pull this container and execute it in your own system. So that was it about our Jenkins pipeline code. Let's go back to Jenkins. Let's just save this. So basically, our Jenkins file consists of 4 tasks. 3 main tasks and 1 is done outside of the code, which is fetching the code from your Git repository. Inside the code, you're going to build a Docker image, you're going to start a Docker container, and then you're going to publish or push that Docker image to your Docker repository. Pretty plain and simple, right? So we saw basically there are 2 ways of building a Jenkins pipeline. The first is via pipeline script. You're going to start out from your Jenkins dashboard, create a new job, and choose the pipeline option and click OK. And then in the pipeline segment, you're going to set your definition as pipeline script. And in the designated place provided, you can start writing your pipeline script based out of Groovy syntax. Then there is the second way in which also you're going to enter an item name and choose your pipeline option. But there is a difference. In the definition, you are going to choose pipeline script from SEM as an option and provide your GitHub path of the Jenkins file and credentials for your GitHub account. In most cases, they're not. Your branch will be specified by default in the field provided below. If not, you can specify the branch that you're working from. Once all of this is done, you can go ahead and click on the Build Now option. And as you can see, it is successfully built. And once it is successfully built, you can go back to your Docker Compose file and look at the execution port, which is 8008. Then you can either go ahead and type in localhost, or you can put in your IP address and you can basically run your e-commerce app. Here you can go ahead, select electronics, fashion, furniture. Let me go down. You can like things, you can add things to cart just as you would in any other e-commerce app. It's pretty functional. Now to run this, first and foremost, you might have to install with other things an Apache web server. That's how you can basically run anything with an HTTP protocol. It's basically going to help you establish a connection between a server and the browsers such as Firefox or Google Chrome, whatever you're using, all while delivering files back and forth between the client and server structure. You can also go ahead and install the Apache Tomcat, which is an implementation of the Java servlet, which is going to help you do the exact same thing. So now that you see what the application looks like, let's take a step back and understand a little more about the technology which makes it all possible. Let's talk about Docker. Now, a lot of you might have heard the term containerization or virtualization. These are very popular terms being thrown around these days. Docker is one of the leading containerization tools. So we're going to talk about three things mostly: the Docker file, the Docker Compose, which we discussed briefly earlier during the demo, and finally the Docker Hub. So Docker is a containerization tool. Everybody knows we have spoken about this technology in the previous session. In this session, we are going to talk a little bit more about the elements of Docker. Now, whenever a developer develops a code, it runs perfectly fine in the developer's environment, in a development environment. But more often than not, it starts throwing errors in a production environment, and that may be due to a few reasons. Might be that the libraries being used in the code might not be installed in the production environment, or there might be certain dependencies which are not being fulfilled in the production environment. So what these developers started to do as a solution is that they started creating Docker images. Now these Docker images had all the libraries, all the dependencies that their code needed to run perfectly. So Docker image is basically a file which comprises of many different layers, and it is basically used to execute code in a Docker container. This image is essentially built from the instructions for a complete and executable version of a certain application. Now, what forms the basis of a Docker image is a Docker file. Now, this is nothing but a text document which contains all the commands a user could call on the command line to assemble an image. And then using Docker build, you as a user can create an automated build that executes several command line instructions in succession. So a Docker file is the core building block of a Docker container. Now it's always recommended to prepare a base Docker image to use the same to derive other Docker images. A base image is just a Docker image which is built with common packages required for all other Docker images. When you run a Docker image build, each instruction in the Docker file creates one file system layer. So this is what a Docker file looks like. It is a YML file, and as you can see, it has got a set of instructions on it using which we are going to be creating an image. This file will tell you the what's and why's of your tasks. So what do we want from it? We basically want a Docker image. We want two of those for PHP and MySQL for our front end and back end, and then we want some sort of an instruction. So here you have instructions to update your package manager and install some utilities or tools which you will be needing. And then the expose instruction informs Docker that the container listens on the specified network ports at runtime, which in this case is port number 80. Then we have a Docker Compose. As I had mentioned before, what Docker Compose does is that it makes it easier to configure and run applications wherein you have multiple different containers, such as the one we saw today. For example, if you have three containers based on WordPress, MySQL, and PHP, in such a scenario, you will be needing a Docker Compose file so that you can run all of those connected containers with a single command. This is a screenshot of the YML file I had shown you previously. You can see our front-end container and our independent back-end database container, as well as environment specifics at the bottom. And then finally, you have a Docker Hub. Now, Docker Hub is a cloud-based registry service. It's like a giant library which allows you to link to code repositories, build images, and test them. It stores manually pushed images and links to the Docker cloud so you can deploy images to your hosts. So this is what your Docker Hub would look like. I have 5 repositories in total, and all of which it's showing here. It's mentioning through the tags that are provided to it. So here you can find various tags that are given to these Docker images To generate these, all you have to do is use the command docker tag the name of the image followed by the name of the tag, which is going to be your Docker repository slash followed by the name of the image. So let me look for Docker images. Okay, you can see the different tags here. All right, so if I had to create a new tag on this job, I'm just going to copy this job and use Docker tag, copy this, followed by the name of my repository slash, again paste the name of this job, and maybe add something new because this name already exists. So yeah, and you'll have to give tags to all the jobs before you try to build on them, because that's the only way they'll run. And once they run and you push the Docker images to Docker Hub, you can execute your app like so. All in all, what you need to understand is that it's less about the tools and services and more about DevOps as a methodology as a whole. And once you get a hang of it, you will definitely be able to use this to your advantage. The demand for DevOps engineers to develop, supervise, and deal with DevOps practices is on a rise in organizations of various industries, and you can meet this demand, raise their own efficiency, and get hired in your dream job by upskilling yourself through this technology. So if you want to learn DevOps, you can go ahead and check out Edureka's DevOps Engineers Certification Training. It'll make you proficient in principles like CI/CD, continuous monitoring, delivery, and in using tools such as Jenkins, Docker, Puppet, Chef, and Git, as well as train you on Linux, Python, Docker, AWS DevOps, as well as Splunk. The curriculum has been designed by industry professionals to give you the best outcome. And if not for your company, you can always go ahead and learn it for yourself. You can do something more with the time this quarantine period gives you and upskill yourself by the time you head back to your workplace. So with that, I close this session. My name is Upasna. Thank you and have a great day.